the area of a curve. We spent the last little bit talking about what a derivative is, right? So here's a derivative. That's a symbol for a derivative of f of x. And as we've been talking about, a derivative is the slope of a tangent line at a given point, right? So I give you here as an x value. I want to find the derivative of x at a. You go to a, draw a tangent line, find the slope of that tangent line. So now we're gonna start talking about integrals, right? So that's our symbol for integral. And yes, a lot cooler than the derivative symbol, but that's our symbol. And what an integral is, it's the area under the curve. So when I say integral, I want you to think area under the curve, because that's what it is. Just like how a derivative is the slope of a tangent line, integral is area under the curve. So you have a curve here from B to C. You want to find the area from there, you integrate from B to C. Yes, the symbol is like an S symbol because it stands for sum. You're summing up all the values from here to here. That's what integral is, area under the curve. So here's a little more formal definition display of it, right? But see how you have a curve like this? You want to find all the area from A to B. We're just going to integrate from A to B. Not my best, but would do. Of f of x. And we put dx. We'll talk about dx later, but it's just letting you know which variable you're taking derivative with respect to. We're integrating with respect to x here. So that's why we have dx. Right, so it's always going to be there. A couple things before we actually talk about how to do problems like this. Here, I want you to notice, right? So over here, it's above the curve. When we integrate that, we're going to get a positive value. Because our values, our areas above the curve. So it's a positive number. Same thing here. We got a positive value. Over here, notice how it's below the x value. If I integrate from -2 to 2, what our f of x here is, dx, again, with respect to x, that's going to be a negative number because it's below the x-axis. Right, so every time you integrate, you find the area and it's below the x-axis, that area should be negative because it's a negative value. And the final thing, the final rule, if you're integrating from A to A, let's talk about it graphically, like from A to A, there's no span here, right? You can't span from A to B. So the integral of a single point is always 0. Because there's no width to it. Like we have to do more than a point. We have to go an actual thing. So anytime you see the the limits of integral, we call those limits. Probably something I should have told you earlier. These are called limits of integrand. Right, so you're going from A to B. So anytime our limits are the same, then it's always 0. So I could use something like 3 to 3 of, it doesn't matter what goes here, but I could put something ugly like x to the 4 plus 5 x to 1 over x dx. Answer is going to be 0 because the answer is always 0. So the limits are match. So those are the few basic rules about integrals. We'll talk about this way more later. For now, the main thing I want you to take back is, right, if you see integral symbol, that means the area under the curve. Just like how derivative means slope of a tangent line, right? Integral symbol means area under the curve. If your area is underneath the x-axis, it should be a negative area. And if the limits are the same, it should be 0 because there's no area to find here if it's 1 point. So let's do some problems. So use graphical evidence and known area of facts to find these limits. So let's do our first integrals. So let's do this first one, A here. So we're going to integrate from 0 to 2 of 2x plus 1 dx. Now again, I haven't touched any tricks and rules how to do this yet, so we're going to do the old-fashioned way, which is find the area underneath the curve. So we have to draw that. Remember, we know how to graph that. It's 2x plus 1, so up 1, slope of 2. So start at 1, go up 2 over 1. That works better if I had a grid, but up 2 over 1. I can do up 2 over 1 again. So it's going to be something like this. Now remember what this says? I want the area from 0 to 2. So from 0 to 2. So start here at 0, go all the way to 2. Trying to find this area. right? So what we do here is we do some basic geometry. This is a trapezoid, so if you know the area of a trapezoid, you can go ahead and do it. If not, you can always separate it to like two things here. Like here's a square and a triangle. Whichever way it works. We're gonna do square and triangle for this one. So this is, so if I want the area of this thing, right, area is blue here, it's gonna be length times width. So this is 2. And the height, look at 1. So area of this is gonna be 1 times 2 is 2. And then let's do the area of this triangle here. I'm trying to try and get all the green. Area of triangle is 1/2 base times height. So my base is still 2, right? That's this. My height, I didn't actually do that, but we can figure it out easy. That's a 2. Just plug it in. 2 times 2 is 4. 4 plus 1 is 5. This is 5. So again, I'm going from 5 to the 1 here, though. That's how high it is, right? Because 1, 5, that's 4. So my area here is going to be 1/2, 2 times 4. So 2 plus 4, integral of that is 6. So right now, that's how you know how to find integral. We just find the area of the area underneath the curve from 0 to 2. So in this case, I had to break it up and make it a rectangle and a triangle, and then just find the area of each one. Again, if you know the area of a trapezoid, you can also do that. So how about the next one? Next one's a little funky. So this here, the integral from 0 to 1 of 1 minus x squared dx. We're gonna try to find area underneath the curve of this. Now you're probably like, how do I graph that? Well, the trick is this is a circle. A circle formula is this. Like a basic circle formula is this. R squared. And what they did is solve for y. So in this case, you're gonna get y squared equals r squared minus x squared, or square root it, y equals square root of r squared minus x squared. And no, that's not r minus x, right? Proper mathematics. You cannot, there's a minus there. You can't separate it like that. So that's what that is. This is a circle formula. So breaking it down more kindly here, this is your radius. So my r squared is 1. Right? The square root of that's always your radius. Square root of 1 is 1. And that's just your x value. That just affects your center. But for us, it's always started at 0, 0. So we'll don't have to worry about that. So we have this. You're starting at 0, 0. Because I don't have a fancy center. My radius is 1. So you go 1 over. 1 up. 1 down. 1 left. You get something to this effect. Right? And actually, I don't get the bottom. Right? There's no plus or minus. It's only the top. So it's only that part. So let me draw that again, because that looks terrible. Go 1 right, 1 left, 1 up. And you only get the top because there's no plus or minus. It's only the top half, so it looks like that. We want the area from 0 to 1, so only this part from here to here. Right, and then how do I find the area? Well, we know how to find the area of a circle. Pi r squared. If you look at it, I only have half a circle, or fourth of a circle there. Sorry, fourth of a circle. So it's that. Then my radius is 1. Right, 0, 1. That's my radius. So plug in 1. I'm going to get 1 squared times pi over 4, so pi over 4. Right, those are first integration problems, right? Integral just means area underneath the curve. So in these cases, draw it to find the area under the curve. Let's go to our last problem here. So in this case, they give me the grid. They want me to find the area of these following things. So we'll do the exact same thing we did before. Right, so let's integrate from 0 to 3. So from 0 to 3. So we got to find the area of all this mess here. That's kind of tough. We could break it down to lots of different ways. We could do like this, and like this, and like that. Any way you want to break it down, feel free to. It's not the prettiest design. Let me just real quick though. So this is 1. That's 1. Okay, so let's do this one. It's 1 times 1, so this is 1. Plus. Now look at here, this goes up to 3. So the length of this is 1 and 2. Right, so area of a triangle is 1/2 base times height. 1/2 1 times 2 is this going to be 1 times 2 is going to be 1. That's also 1. Right, just base times height. This big rectangle here, well, this is the length here is 1, and it goes all the way up to 3. That's terrible. So it's just 1 times 3, length times width. So 3. And then this final little triangle here. Again, this length here is 1, it's only 1 across, and you go 3 up. So it's 1/2 base times height. 1/2, 1 times 3. Oh, that's going to suck. That's 3/2. So, area of all that's 3 plus 4 plus 3 plus 1 plus 1 is 5. 5 and 3/2. So, oof, this is like 1 and 1/2. So 6.5. 6.5. Again, messy, ugliness. But that's the general idea. You find the area underneath the curve. B. 3 to 7. And by the way, this is the only way we can do this one. There's no formula here. So if you have a grid with no formula, you just got to do this way. Now look, they want the area from 3 to 7. So that's from here to here. First thing I want you to notice, it's underneath the curve. So our answer is to be negative, right? It's underneath the x, I should say underneath the x-axis. So our answer is to be negative. Same concept. We got to find the area of this mess here. Break it down any way you want. Let's say we'll do that. Probably do this. This. I could live with that. Right, area of this, the big old, we're going from 5, 6, 7. That's 2 across. And that looks like it's 2 down. So this is 4. Again, negative. Because we're going beneath the x-axis. This would be 1 across. And then it's 3 down still. So 3. Negative 3. This is 1 and 1. So again, 1/2 base times height. That's 1/2 times 1. Just 1/2. And then this one, that's 1 across and 3 down. So 1/2 base times height. That's going to be 3/2. Again, all negative. So negative 7 plus, hey, this actually works out. Negative 4 over 2, which is this negative 2. So negative 9. So area from 3 to 7, just negative 9. Area into the curve. C. From 2 to 4. So they want from here to here. Now I already did this part, right? We did that. We got 1.5, if I remember correctly. About 1.5, 1.5. And then we did this part. And that's what we did over here. We got negative 1.5. So the actual area from there to there is just going to be 0. Right? We had this side, which was a positive. That side's a negative. And they do cancel each other out. So you just get 0. Then this one right here. Integral that's a 0. And then finally, let's do the last one, which is the integral from 0 to 7. So I want you to add up all this from here to here. That's a terrible straight line. Oh my god. Right, from there to there. Now, we looked out. We already did this half. Right, we know what that half equals. That half is 6.5. And then we figured out what this half was. In that mess, in that Jason Pollock painting right there. That was a negative 9. You add them up, you get negative 2.5. And that's integration.